Last part of this first section is factoring a polynomial by pulling out a GCF. My hope is this is something that you're pretty comfortable with. I just want to remind you that GCF just stands for greatest common factor. The idea being is I want to pull one thing out that is the most possible that I can pull out. So I'm just going to jump into two quick examples to give you an idea of what you might see in the homework related sections. So one right here, let's go 10x cubed plus 4x squared minus 16x. Essentially all I'm doing is I'm trying to see what is in common to all three terms, and I'm going to pull it out like I'm doing a reverse distributive property, if you will. So I think it goes without saying that if we looked at this problem right here, we recognize that every single term has an x in it, and at most I have one x I can pull out. So I know I'm going to be pulling out an x. I'm also looking at the numbers of 10, 4, and 16. And one of the things that's helpful is to look at the parts of each of these. So for example, my 10 has a 2 and a 5. Now my 4 also has a 2. In fact, it has a second 2 as well. My 16 also has a 2, and it has an 8. And it's got more than just that 8. I could break that down even further, but the moment I pull one of these 2's out, 5 doesn't go into the other numbers, so there's nothing in common the rest of the way. Ooh, excuse me. So the most I can pull out is that 2. So I'm going to go ahead and pull that 2 out. And what I want to imagine right now is if I pull that 2x out, I want to think about what's left in each of these spots. If I pull this 2x out, I still need a 5x squared. 2x times the 5x squared will give me 10x cubed. For this middle term, I still need a 2x. 2x times 2x gives me a 4x squared. And then finally, for this last term, if I pull out a 2x, I still need a minus 8. 2x times a negative 8 is a negative 16x. If you look at these remaining values in the parentheses, there is no more I can pull out. 5 doesn't go into 2 and 8. There isn't an x on this term, so I can't pull out an x, and that is all I can take out. Now, if we were trying to, quote, factor completely, in order to factor completely, we would look at what's left in our parentheses and see if we could break it down again into smaller parts. For our purposes on this assignment, we're just trying to pull out a GCF. We do not need to worry about looking again inside of those parentheses. So just realize that that's the goal right there. Now, let's look at another one. Same idea. So this one right here, we got a 12x to the 5th minus 18x to the 4th plus a 30x cubed. Looking at this one right here, same idea. We want to look for a GCF, or what's in common to all terms. So again, same as the last one, I'm going to look at my x's first. Sure enough, I have an x, I have an x, I have an x. However, I can get a little bit more precise than that. Right here, I have not one, but 3 x's. This one has 4, this one has 5, which means I can pull all 3 out because I'm still going to have 3 x's in each spot, so I have x's to remove. I'm then going to look at my numbers. I've got numbers of 12, minus 18, and 30, and it can become a bit of a challenge to figure out, well, what can I take out from one and not the other? But playing around with a little bit, you just want to pull out the most you can. And if you don't pull out enough, you can just check and see what's left over. So I'm going to do that right now. I'm going to do a hypothetical where all I do is I pull out a 2. And some of you might recognize that that's not the final answer, but just go along for the ride with me. Suppose I decide to pull out a 2. Okay, this spot right here, to turn the 2 into 12, I need a 6. To turn the x cubed into x to the 5th, I need an x squared. Second term, to turn my 2 into a negative 18, I need a minus 9. x cubed to x to the 4th, I still need 1x. And then finally the last spot, 2 to 30, I need a 15. And I just have an x cubed, so that's it. Well, look inside your parentheses for a second. 6, 9, and 15. Do all those numbers have something in common? Pretty sure they do. They've all got a 2 or a 3 in them. And the fact that they've all got a 3 in them means that that 3 can come out in front. And when it comes out in front, it's going to combine with that original 2. So 2 times 3 gives me 6. There's my x cubed. What's left? First term is a 2x squared. Second term, I had a 3 left over, so minus 3x. Last term, I had a 5 left over, so plus 5. And we can double check this back to the original. 6x cubed times 2x squared is a 12x to the 5th. 6x cubed times a minus 3x is a minus 18x to the 4th. And a 6x cubed times a 5 is a plus 30x cubed. Now that does mean in the very beginning, you could have just pulled out the 6. If you recognize that 6 went into 12, 18, and 30, you could pull out the 6 from the beginning. But I showed it to you in 2 steps just so that you see, even if you don't get it all on the first try, check to see what's remaining, and there may still be some left over.